Let's discuss today's Geeks for Geeks problem of the day. Make matrix beautiful. A beautiful matrix is defined as the square matrix in which the sum of elements in every row and every column is equal. Given a square matrix, your task is to determine the minimum number of operations required to make the matrix beautiful. In one operation, you are allowed to increment the value of any single cell by one. So you have given a matrix and you have to make every column and every row has a sum equal, right? So, and for that, you can make operations. In one operation, you will add 1 to any of the cell, right? You just have to make sure that every row and every column has the same value. And you have to return the minimum number of operations to achieve that. If this condition is not given, then you can easily think of a solution. Then in that case, you will make every element of this matrix to be equals to the maximum element of the matrix, right? You can make 4 to each of the list of the elements, and it would always have the row sum and column sum equal. But for that case, you will be requiring two operation for this cell, three operation for this, and one operation for this. 1 plus 3 plus 2. It would be 6 operation. But its answer is 4 because we have to return the minimum number of operations to achieve the goal. Okay, let's see this example also. So here plus 1 plus 2 plus 3, and basically you can see this row has the maximum sum among any of the row or column, right? It has 9, so this row should also be 9 because we can't decrement a value, we can just increment a value. So I have to make sure that every row has the value equals to the maximum value, maximum row sum or maximum column sum. Because if column has the maximum sum among any of the lower column, then I have to make sure that every row also have the that same value, because the same reason I can't decrement the value. I just have to increment and make sure that I achieve that state. That state would be the maximum sum among any of the lower column, so that we can ensure that we will surely achieve a solution. And by incrementing some cells, I would be achieving the goal, right? Okay, so for this case, we can make plus 3 operation for this row to make the sum equals to the 9, and here the sum is plus 6, so I will be requiring plus 3 to make it also have sum equals to 9. Okay, so hope the problem statement is now makes sense to you. Okay, so basically the major portion I have to make sure that any of the row or column which have the maximum sum. So I have to make sure that every row and every column should also have that sum, right? And if you start thinking uh, with both row and column at the same time, then it would be a lot complex and difficult to analyze and reach to a solution. Let's just go with row by row or column by column. And we have one data here that okay, this row has the maximum sum among all the rows and columns. So let's go with row wise, and I have plus 9 here and I have plus 6 here. So I have to add plus 3 to this row. I can divide the plus 3 among all the 3, or maybe one of the 3 or two of the 3 elements. But surely I will be requiring plus 3 to make the this row sum equals to be the maximum row sum, right? That is plus 9. And here also I will be requiring plus 3. So it's in our hand that I can distribute the required plus 3 operations into any of the row, right? I have plus 3, I can divide plus 3 as like I add plus 1 to this row, plus 1 to this cell, plus 1 to this cell. It would be it would lead to a row sum equals to plus 9, right? So I can achieve the row sum equals to the maximum row sum by dividing any in any of the possibility for the number of operations required for in that row, right? So, but I have to also ensure that column sum should also have the same value, right? Just take it for a minute. Let's take this example, right? S- So this row has plus 6, and I have to add plus 3 to this row and plus 3 to this row, and this is the maximum. So, okay, now I have plus 3 in our hand, in our pocket. I can give to any of my child, right? If you assume that you are father and you have three child, so you can give this much money to any of the child in any of the order, right? So okay, but I also have one more condition that the column sum should also be equal. And now it's up to us that I divide that plus 3 in any of the order, right? So let's analyze the columns sum also. So this column has plus 4 plus 4, sorry, 4 plus 3 plus 1, it would be 8, right? So it requires plus 1 operations to make this column sum have the maximum sum, that would be plus 9. So you have plus 3 for this row and plus 3 for this row. You can add plus 1 to this cell or this cell, right? Uh, yeah, by using plus 1 operation, right? So let's assume I spent here and I made, so let's assume that I am spending plus 1 operation to this one, right? Now, sorry, it was 3. So I, after spending one operation, it would be 4. So this column has the sum plus 9, right? Okay. Now comes to this column, it has sum plus 6, and I have to make it plus 9. So, okay, what if I add all the plus 3 operation to this cell itself? It would be plus 5 now. And this column has a sum plus 9, which is equal to the target. Okay, let's come to this column. Now this time I have 0 operations left because I have spent all the operations to this cell. Okay, now this column 33617. I have to add, I have to make two operations. It has 0 operations, so I would go for this one. It has plus 2 operations left because I had spent plus 1 operation here. Okay, so I would make plus 2 operation here and it would be plus 3. Now you can see that okay, all the columns and all the rows has a value equals to the maximum sum, right? Which is equals to 9. So okay, we have we have this solution, and also we also have this solution also, right? Means we can achieve more than one solution for this problem, and we just have to return the number of operations. So uh, we can achieve any of the goal, right? And why this is it possible to achieve multiple solution? Because it's we have the power to distribute the number of operations for a particular row or particular column, right? Since we have the power, so we can decide like for to achieve this solution, you would spend plus 1 operation here and plus 2 operation here. This will have the solution plus 9, and since this column now has plus 9, it is correct. Now it has 4 plus 2, 6 plus 2, it would be it was 8, and adding plus 1 operation to this cell, it is plus 9, right? And um, adding plus 2 here also, it make the plus 9. So I can distribute the number of operation for that particular row according to the condition that I have to make sure the column sum should also be same. Okay, which should be same, and it should be equal to the maximum sum, which can be of any of the row or any of the column, right? Okay, so basically we have created a intuition in our mind that okay, I would be taking firstly, I would be checking for the maximum sum among any of the row or any of the column, right? So I have done the same thing. I I iterate over all the rows first, then I iterate over all the columns then, and take the maximum sum among each of the row, and actually it yeah. So I done this, and okay. So I stored the maximum among the basically all the rows and columns. So I'm just comparing if the maximum sum lies for a row, then it would I will be uh, going going row wise, and else the if one of the column has a maximum sum, then I will be going column wise, right? Because if row has a maximum, I just have to add the extra operations to make other row sums also be equal to the maximum row sum. Then it would internally manage to achieve one more goal, that is to make all the column sum also be equal to the any of the row or any of the column sum, right? So it would achieve internally itself. So I just need not to manage the other situation also, right? If I'm going row wise, I do not require to think for column, and if I'm going column wise, I don't require to think of row, right? Okay, so at the end I just doing the same thing. If maximum row sum is the greater, then I'm making operations by just taking difference of the maximum row sum and the sum of that row, right? Okay, so for that, for using the particular row sum here, I'm storing into an array, because if I'm not require this particular row sum at the end, then I can make one single variable which would be storing the maximum sum among any of the row or column directly, right? But I have to implement a logic that okay, either we have to go for row wise or column wise. So to decide between these two different ways, I have to store the particular row sum and the column sum to decide accordingly, right? So basically, this is the complete intuition and the approach. Hope this solution is much clear to you. And the most important part of this question is to build a perfect intuition and a solution. Intuition is must and intuition is difficult a little bit also, because people start taking care of both row and column at the same time, and they messed up himself or herself in the problem, and at the end they didn't get a perfect solution, right? So take care one by one, and it would be possible, like in this case, it would be possible that the other thing it is manageable itself, right? So go with one, you will have better understanding for the second one also. Okay, thank you.